Hello, fifth grade, and welcome to lesson 5-5, which is titled Using Sharing to Divide with Two-Digit Divisors. So let's go ahead and watch our short video lesson here, and then jump into our notes and our guided practice as always.
How can you record division with a two-digit divisor? Orchard workers have 258 grapefruit seedlings to plant in 12 equal rows. How many seedlings will be in each row? 258 divided by 12 is close to 250 divided by 10 equals 25. You can think about place value and area models to solve the problem. Regroup the blocks to fill the 12 rows. What is 25 tens divided into 12 equal groups?
Select your answer.
Okay, so here they're asking us to figure out what is 25 tens divided into 12 equal groups. So 25 tens is 250, right? So we're going to divide 250 divided by 12. Now 25 divided by 12 will only give us about 2, right? 12 times 2 is 24. So it's going to be about 20 here.
25 tens divided into 12 equal groups is 2 tens in each group. 12 groups of 20 equals 240. 18 ones divided into 12 equal groups is 1 in each group. 12 groups of 1 equals 12. 6 plants are left over. 258 divided by 12 equals 21 remainder 6, because 12 times 21 plus 6 equals 258. There will be 21 seedlings in each row with 6 seedlings left over.
Okay, so let's stop and take a look at what they did here. Now here they did the regular long division, like what we've been talking about, the more traditional version. So 25 tens, right? So how many 12s go into 25? Well, we know there's two groups of 12 and 25. 12 times 2 is 24, or 24 tens, which gave us the 240. They subtracted that off, and they were left with 18. Now there's only one group of 12 and 18. So they put the 1 up here, subtracted off the 12, and they're left with 6 extra. So that remainder is 6. 6 is not going to fit evenly into this particular area. So those 6 seedlings are left over and they're not going to fit in the garden. Let's go ahead and take a look at our notes and guided practice for more examples here. So using sharing to divide with two-digit divisors, how can you record division with a two-digit divisor? So let's take a look at an example of how we can do this. The recycling club has $294 to purchase one set of recycling bins for each of their 14 members. What is the greatest amount that they can spend on one set of bins? So we have 294. We need to divide that by 14, and that's going to give us C, the cost of one set of bins. So whatever number we get here is the most that they can spend per person to have enough for all 14. So 14, we need to think about how many groups of 14 go into 29 or 29 tens, because we're working here. This digit is going to be in our tens place. So we know 14 times 2 is 28. So 14 times 2 tens would give us 28 tens, or 280. So we did the 29 over here, the 29 tens minus the 28 tens left us with 110. And then we dropped our next digit, which was a 4. So 14 goes into 14 one time. That's easy. So we put the 1 up top in the ones place, and we subtract off the 14, and we have no remainders. So the most they can spend on each set of bins is going to be $21. Now, just to make sure, we're going to do the inverse operation and multiply. We're going to do the 14 times the 21. So we find our partial products and we add them together, and we did get back to 294, which is the original amount of money that was mentioned in the problem. So by doing the inverse operation, we check to make sure that we did our work correctly. So each set of bins can cost at most $21 so that they can purchase enough for all 14 of their members. All right, let's take a look at another example. It says the scientist needs 72 milliliters of distilled water for each of 15 experiments. She has a bottle that contains 975 milliliters of distilled water. Is there enough for all 15 experiments? Well, what I know is she needs 770, sorry, she needs 72 milliliters per experiment. She has a total of 15 experiments, and she has 975 milliliters of water. So there's also a hidden question in here. Well, first we need to figure out what is the total that she needs for all 15 experiments so we can figure out if what she has is enough. So to find that, the answer to that hidden question, we're going to take the 72 milliliters that are needed times the 15 experiments that she needs to do. And when we multiplied those and added our partial products, we got to 1,080 milliliters. So we know that she needs 1,080 milliliters of distilled water for all 15 of her experiments. Now, since 1,080 is greater than 975, which is what she has, we know that she does not have enough water for all 15. Now, you could have also solved this by dividing, but one of the things you always need to remember is to look for and solve those hidden questions that are in the problems. Now, if we were to solve this by dividing, we could take the 975 and divide it into groups of 72 to see if it equals at least 15, right? Because 975 milliliters of water divided into groups of 72 milliliters, if it equals 15 or more, then she has enough for her experiments. If it doesn't, then she does not have enough. Now, if we take the 975 divided by 15, the 975 divided by 72, we know there's one group of 72 in 97, right? So I subtract off the 72 and I'm left with 25. Then I drop my other 5 down. Now I have to think how many groups of 72 are in 255? Well, 72 times 3 gets me to 216. That's as close as I can get. So I subtract off the 216 from the 255 and I have a remainder of 39. So my quotient here is 13 remainder 39. Now 13 groups of 72 with an extra 39 milliliters is still less than the 15 experiments she needs to do. So here, when we divided, we found out that she could do 13 whole experiments and have 39 milliliters of water left over. But she doesn't need to do 13, she needs to do 15. Now, since 13 is less than 15, we know again that she does not have enough distilled water for all of her experiments. She only has enough for 13 of her experiments. All right, let's take a look at another example before your guided practice. It says Ivan has 30 craft sticks to make each toy cabin. He has a box of 342 craft sticks. How many cabins can Ivan make? How many sticks will be left? So here they're asking us to find the quotient and to figure out if there is a remainder. So I need to take my 342 and I need to divide it into groups of 30. So I know there's one group of 30 in 34, right? So I'm going to write the 1 above that last digit that I worked with, which is a 4. So 30 times 1 is 30. I subtract it from 34. I end up with 4. And I drop my next digit, which is a 2. So now I have 42. 30 goes into 42 only one time because 30 times 2 is 60, and that's too much. So 30 times 1 is 30. I subtract the 30 from the 42, and I'm left with a remainder of 12. So here I can see that 342 divided by 30 is 11 with a remainder of 12. Now I'm going to take those numbers and multiply them by each other and then add in that remainder to see if I get back to 342. So 11 times 30 is 330. 330 plus the 12 that was remaining got me back to 342. So I know that Ivan can make 11 whole cabins and he's going to have 12 craft sticks left over. All right, next let's take a look at your guided practice. It says if the orchard has 200 seedlings and 12 are planted in each row, how many rows will be filled? So Here we have new numbers to that same question that we were talking about in our short video lesson. Now, if I have 200 seedlings and I want to divide them into 12 rows, I'm going to take my 200 and I'm going to divide it by 12. Well, there's only one group of 12 in 20. So 12 tens can only, 12 tens is 120. I can't do 12 times 20 because 12 times 20 is 240, or 12 times 2 is 24, because remember, we're working the tens place. So I can't do 2 over here because that would be greater than the number I'm working with. So 12 times 1 is going to give me 12. So I'm going to do that 20 minus the 12, which is going to leave me with an 8 remainder. And then I'm going to drop my 0. So 12 times 6 is as close as I can get to 80. So 12 times 6 is 72. 80 take away 72 is 8. So here I will have 16 complete rows with 8 left over. Now, if I do the 12 times 16 over here, the 10 times 10 is 100, 2 times 10 is 20, 10 times 6 is 60, and 2 times 6 is 12. If I add all of those, that gives me 192. My total, which was a 200 minus the 192, shows me again that that remainder that I had left over was 8. So if I did the 12 times the 16, I would have gotten 192, plus the 8 left over would get me back to the 200 total seedling. So 16 rows will be filled, and I'm going to have 8 seedlings left over. Number 2 says, in problem 1, what does the remainder represent? So the remainder is the 8 seedlings that do not fill a whole row. Next, we have numbers 3 and 4. So we have 196 divided by 14. We know 14 doesn't go into 1, but 14 goes into 19 one time. So I put the 1 over there above that last digit, which is the tens place. I subtract off my 14 and I'm left with 5. Now I drop my next digit, which is the 6. 14 goes into 56 4 times. So 14 times 4 equals 56. I subtract it off and I have a 0 remainder. So then I'm going to put my numbers together and use my inverse operation of multiplication. I'm going to do the 14 times the 14 to see if I get back to my original dividend. So 14 times 14, I found my 2 partial products. My product here was 196. That matches my dividend in my division equation, so I know that my work is correct. For number 4, we had 766 divided by 80. Now, 80 doesn't go into 76, so we have to look at the whole number. So 80 goes into 766 9 times, because 9 times 8 is 72. So 9 times 80 is 720, and that leaves us with a remainder of 46. Now I'm going to use my inverse operation and multiply. We just said that 80 times 9 is 720. 720 plus that 46 remainder got us back to 766, which was our original dividend. Remember to always use your inverse operation to check your work. This is really important, and it helps you catch silly mistakes that happen all the time. So please do your work carefully, show all of your steps, and use your inverse operation as a final check to make sure that you did everything correctly. That's it for this lesson. If you have any questions, let me know. Otherwise, have a great day. Take care. Bye-bye.